In this lesson, we're going to look at what we call radical equations. I'm only going to do some examples that have actual just square roots in them. So it's this radical part, but we're only going to look at the square roots. You could have cube roots, fourth roots, and so on, but you're only going to be responsible for those square root problems. So key here, you absolutely must check your solutions. And when I say check your solutions, you actually have to plug it back in here and make sure it works. I'll explain why when we get to the solutions of this first example. So in this problem, you have the square root of 4 minus 6x equals 2x. So how do I get rid of that square root? Well, the inverse operation of squaring, our square root is squaring. So I get, let me change the color here, 4 minus 6x equals 4x squared, because the square root of 4 minus 6x, quantity squared, is just going to be that 4 minus 6x. At this point, look, do I have a quadratic, linear, or some sort of polynomial equation? Since I have that x squared, I have a quadratic equation. I'm going to want to set it equal to 0. Since this is a positive 4x squared, I'm going to bring these both over on that side. So I have 0 equals 4x squared plus 6x minus 4. Okay, so now I have to decide quadratic formula or use factoring. I'm going to use factoring on this one because it is factorable. And you'll notice that the first thing I can do is take out a 2. Instead of factoring out a 2, I'm going to show you that if I actually take this whole side and divide by 2 and divide by 2, as long as I do it to both sides, I don't have to worry about that 2 out front. So I just have that here. This is factorable. What multiplies to give me negative 4 and adds to give me 3. So I'm going to have 4 and negative 1. This is 2x and x. So if I look at this times this needs to give me, it can't give me negative 1, so it has to give me a 4. So this will be a 2. And this one's going to be a minus 1. So this times this gives me negative 1. And then when I multiply these two, I'm going to get my negative 2. Using my zero product property, I get x equals 1/2 and x equals negative 2 are my two solutions. So that's what I come up with for my solutions. I stop there and I am not going to be 100% correct, because watch what happens when I go and check this one. We'll start with the 1/2. I have the square root of 4 minus 6 times 1/2 has to equal 2 times 1/2. So I get the square root of 4 minus 3, which is the square root of 1, has to equal 1, and that's true. Now if I check the second one, I have the square root of 4 minus 6 times negative 2 has to equal 2 times negative 2, and you may notice right away what my problem is. I get the square root of 16, but what does it equal? Negative 4. And the square root of 16 is positive 4. I don't have a plus minus here. When I squared both sides here right from the start, what I did is I made this whole side positive and this whole side positive, because by squaring it, we make things positive. And that's not the case. 4 squared equals negative 4 squared, but 4 does not equal 4. So that is not actually a solution to my original equation. It's a solution to this equation, okay, but it is not a solution to this one that I started with. My only solution is going to be that x equals 1/2. In example number 2, you'll notice I have the square root of x minus 7 plus 5 equals 10. Well, when I square both sides, I square the entire side. So if I'm going to square this, I have to square this whole thing and this whole thing. I don't want to square this whole thing, okay, because then I'll have to FOIL it because of this plus sign here. So my first step is to get this square root by itself, and I can do that by subtracting 5 from both sides. Okay, and so then I get an equation like this. Now, if I square this side and I square this side, I'm good. I just have the square root of x minus 7 quantity squared, and that's going to give me, let me just write this, if I square and square, that's going to give me x minus 7 equals 25. And if I look at this equation, I do not have any x squared, I just have my x. This is a linear equation, so I just need to get my x by itself by adding 7 to both sides, and I get x equals 32. Now, let's make sure we check this. So the square root of 32 minus 7 plus 5 has to equal 10. This is the square root of 25 plus 5 equals 10. So 5 plus 5 equals 10. And that definitely works. So I'm good on my solution of x equals 32. This following example, I actually have the square root of 2x minus 5 equals the square root of 5x minus 8. If you remember, when you solve an equation, you're trying to find the value of x that makes this statement true. So I really just need the 2x minus 5 to equal the 5x minus 8, because then when I take the square root of each of those, I'm going to get the same thing. So technically what we're doing is we're squaring both sides. We're saying this squared and this squared. But if you think about it, you just need to make sure what's inside that radical is the same. I end up with 2x minus 5 equals 5x minus 8. And is it a linear quadratic? I don't have any x squareds, I just have x's. So all I need to do is get the x by itself. I'm going to subtract 5x and add 5. And I get negative 3x equals negative 3, so x equals 1. Okay. Now I need to make sure I check this. The square root of 2 times 1 minus 5 has to equal the square root of 5 times 1 minus 8. And this is going to give me the square root of negative 3 has to equal the square root of negative 3. And that actually is, even though these are imaginary, that is actually a true statement. In my last example, I once again have this square root of x plus 5, but then the plus 1 equals x. This one actually is going to be harder than my second example because of the x being here. So when I bring the 1 over, I can't combine it with the x, so I just have to write x minus 1. And when I square both sides, I have to square the entire side. So what happens here is I get x plus 5, but my right-hand side is x minus 1 quantity squared. This needs to be FOILed. It is not x squared minus 1. Do not make that mistake. This is going to be x squared minus 2x plus 1. And so now I have actually a quadratic equation. So since my x squared is positive, I'm going to bring everything over to that right-hand side. I'll subtract the x from both sides, and I'll subtract the 5 from both sides. And this isn't bad because I have something that's factorable, and it's the easy kind of factoring. What multiplies to give me negative 4 and adds to give me negative 3, negative 4 and 1. So I get x minus 4, x plus 1. And so I get x minus 4 equals 0, x plus 1 equals 0, x equals 4, x equals negative 1. And now remember, I need to check. So I go back over here. I'm going to check my 4 first. I get the square root of 9 plus 1. And that's a true statement. So this one's good. And I check the negative. So I have the square root of 4 plus 1 equals negative 1. 3 plus 1 equals negative 1. And that is not true. I have 4 equals negative 1. So my negative 1 actually does not work. So to summarize everything, when you're dealing with the radical equations, the key is to check your solutions. So as you're going through all of these, just make sure that once you come up with your solution, you always check both of them, because sometimes one works and the other one doesn't. Sometimes neither one works. Sometimes they both work. So you have to make sure you check your solutions. Also, once you're squaring both sides and you get something that looks like this without the square root, you have to decide, is it quadratic or is it linear? And then use the right method to solve, whether it's quadratic or whether it's linear. So a lot of people mess up. They think they solve this like a linear equation, and you can't. Okay?